Good morning, everyone. My name is Ruchita and I am from CSC AIML Section C branch. So, I am going to talk about object oriented programming. The subject name is object oriented programming and the topic is object oriented design for power system applications. So, let us begin. First, what is the agenda of the topic? The agenda of the topic is Introduction to Power System Applications, Overview of Object-Oriented Design, OOD Principles, Mapping OOD to Power Systems, example of class models, UML relationships, implementation and case studies, advantages and challenges, conclusion and further trends. So next, power system overview. So first is complements. In complements we have generation, transmission, distribution and load. Next, functions. Monitoring, control, stability, optimization, need for accurate modeling and stimulation tools. Traditional systems, procedural and static models. Why software design matters to us? Let us know about it. Modern grids depend on simulation and automation. Traditional procedural code is hard to maintain. Dynamic requirements, renewable integration, smart grids. OOD provides structure, modularity, and reusability. Next, what is object-oriented design? Software design method focusing on objects. Objects is equal to data attributes plus behavior methods. Based on classes, inheritance, and polymorphism, improves modularity and reduces redundancy. Next, what is key OOD principles? Encapsulation, abstraction, inheritance, and polymorphism. First, let us know about encapsulation. Group-related data and methods are called as encapsulation. Next, abstraction. Hide unnecessary complexity is known as abstraction. Inheritance. Inheritance means derive new classes from existing ones. Next, polymorphism. Use a single interface for multiple forms. Next, OOD in power systems. Complements like bus, line, generator, load modeled as objects. Each object knows how to compute its own values. Power systems class coordinates their interactions, enables modular stimulation and real-time analyzement. Next, first, what are the examples of power system classes? Let us know some examples about them. So, the examples are class, attributes, methods, bus, ID, voltage, angle update voltage, get power, line from bus to bus, R, X, calc loss, calc, admittance, generator, capacity, cost, efficiency, generate power, control output, load demand, type consume power. And let us go to the next slide. So, this slide UML relationship diagram. First is association. What is association? Bus connected to line is called association. And next about aggregation. Aggregation means power system contains buses and lines. So next, inheritance. Synchronous generator and wind generator and solar generator. These are the inheritance. Next, this is an example of a Python program. So implementation example Python. So class bus, def unroot int, in it self ID voltage. This is about class bus. This is the example of class bus, and this is the example of class generator bus. And next is def generate self demand. I hope everyone understood the example. Next, OOD applied to load flow analysis. Each complement computes its own contribution. Power system dot solve load flow coordinates all points, all components as well as points. Easier debugging and extension. Reusable across multiple analysis tools. What are the main advantages of OOD in power systems? So, the main advantage of OOD in power system is modular and reusable components, easier maintenance and testing, supports multidisciplinary teams, enables real-time stimulation and control integration, ready for smart grid and AI applications. Limitations and challenges requires advanced design skills, slight performance overhead for large systems. Interface standardize is critical. Integration with the legacy procedural system is complex. Next, about future directions. What are the future directions? So, the first point is integration with AI and machine learning. Next, hybrid OOD plus functional programming. Next, model driven engineering is called as MDE in smart grids, cloud based power system stimulation platforms. Conclusion: OOD enhances modularity, flexibility, and scalability, provides a strong foundation for smart and digital grids, promotes collaboration between software and power engineers. Think in objects, model the grid like the real width. So, what are the course outcomes? So, the first course outcome is explain the fundamental concepts of OOD, means object oriented design, and its key principles like encapsulation, abstraction, inheritance, and polymorphism. So, what is Bloom's level? It is understand. We have to understand these things. What are those? These are key principles of object oriented design. So, the key principles of object-oriented designs are encapsulation, abstraction, inheritance, and polymorphism. So, what is the second course outcome? Analyze the structure and operation of power system components and map them into object-oriented models. So, what is its Bloom level is analyze. We have to analyze. The first thing of course outcome 1 is we have to just understand the meanings of these words. But in course outcome 2, we have to analyze the models and map them. So, what is the third course outcome? So, the third course outcome is design class structures and relationships. So, using UML diagrams for various power system applications such as load flow, fault analysis, and stability studies, Bloom's level is apply and design. We saw in first course outcome 1 and 2 we have to understand and analyze, and in third course outcome we have to apply the design. Okay. Next is course outcome 4. Develop and implement object-oriented programs in languages like Java, C++, or Python for stimulating and controlling power system operations. In this Bloom's level is apply and create. So, next course outcome is next is evaluate the performance, modularity, and maintainability of object-oriented models in comparison with traditional procedural power system softwares. So, I hope we all had these 5 course outcomes. And the sixth outcome. So, what is the outcome for our course outcome 5? It is Bloom's level evaluate. So, next, what is the course outcome 6? Demonstrate teamwork and communication skills through project-based learning presenting OOD-based power system, stimulations or protocols. So, what is the level of this? It is apply and demonstrate. So, in this object-oriented program, we have learned all these 6 course outcomes. So this is a quote. It is software engineering and power engineering share one truth structure defines strength. So it is written by IEEE Power and Energy Society Inspired Concepts. So I hope you all enjoyed the 5 course outcomes. I think I am clear with all these courses outcomes. So I want another thing to tell you that all of you understood the 5. I hope all of you understood the 6 outcomes. Those are we have to analyze, we have to understand, we have to analyze, we have to demonstrate, we have to create a design by learning this object oriented program. So let's go to the next topic. Object-oriented programming finds extensive application in power system analysis and simulation due to its ability to model real-world power system components as objects. This approach offers benefits in terms of software development, maintenance, and extensibility. I hope you all got. And this is the code at the end. It is software engineering and power energy engineering share software engineering and power engineering share one truth. Structure defines strength. This is from IEEE Power and Energy Society. Inspired concepts. Okay, so I hope you all understood the object-oriented programming in power systems. So this was the code at the end. We also seen the course outcomes. So we also had seen the course outcomes. We had a code at the end. I hope you all understood clearly about the course outcomes and thank you.